so yesterday we figured out that there were 3 methods to proving triangles are congruent. Who can give me one? Side, similarity. I'm not congruent, sorry, similar. What's another one? Angle. And the third one? Side, angle, side. So those are the 3 ways that you can prove 2 triangles are similar. Remember, we're not saying they're exactly the same. We're saying like one is like a mini-me version of the other. Okay? So number 1 says RKRA and FLN similar. And how do you know? Are they? How do you know? So you've got 2 congruent sides, right? You've got one angle, but that one angle is not the included one, right? If it was up here, it's an automatic yes, but it's not there. But what do we know about an isosceles triangle's angles? Sort of. Like, if the 2 sides are the same, then the angles opposite them are also the same, right? So because these 2 sides are the same, these 2 angles would also be 71. So those would be the same, right? They're called base angles. And so, again, still I don't have side angle side, but if I add those 2 together, 71, 71, I get 142 subtracted from 180. I get that last angle is 38 for both triangles, right? So now I have 2 options. I can either say they're similar because of side angle side, or side angle side similarity, or angle similarity, because I have 2, actually I have all 3 angles the same. So straight from the picture is not enough information because that angle is not the included angle. But because they're isosceles, I know the angles opposite them are also congruent, and if that's the case, then it's angle. If I wanted to find that third angle, which is that 38 at the top, then it's side angle side. It's both, yep. Or either or. You don't have to put both. You can just give me one. All right, number 2 says a flagpole can cast a shadow 18 feet long. At the same time, Rachel casts a shadow that's 4 feet long. If Rachel's 5 feet tall, what's the height of the flagpole? So you've got a flagpole. You don't have to draw it, but if you're a visual person, you can. You've got a flagpole with a shadow. The shadow is 18. The flagpole is what we don't know. And then you've got Rachel. She's got a really long neck. And she's got a shadow. Rachel, her shadow is 4 feet, and she is 5 feet tall. So this is where you set up a proportion, and you can do this a couple of different ways. I can say that the thing creating the shadow here to the thing creating the shadow here, or 5 to x, would equal the shadow to the shadow. Or I can say what it's creating to its own shadow, so x to 18 equals what's causing the shadow to the shadow, which is 5 to 4. Either way, you end up with the same answer. If you look at it, this is actually that left to right gets this. That's one of the properties of proportions. So from here, I would reduce this. What goes into both 4 and 18? 2. This would be 2 and 9. So I get 5 over x equals 2 over 9. And then I cross multiply. 5 times 9 equals 2 times x. Divide both sides by 2. Well, actually, let me multiply that out first. 2x would equal 45. Then divide both sides by 2. And remember I said as long as it's simplified, which 45 over 2 is simplified, you can leave it that way. Or you can convert that 45 divided by 2. $22.5 or 22.5. So any of those 3 answers are good. So again, you can either go flagpole to person, so that the thing that's causing the shadow to the thing that's causing the shadow equals the shadow to the shadow, or you can go, God bless you, flagpole to shadow equals person to shadow. Either way you set up that proportion, you're going to cross multiply and divide. Questions on that one? 3 says, are the two triangles similar? If so, write a similarity statement. So in order for these to be similar, I either need to know two angles, which we have nothing about angles. I need to know two sides in an angle, still don't know anything about angles. Or all three sides, right? What do I have this time? All three sides on both. So I'm going to set them up. Even though it's rotated, I'm going to find small to small, middle to middle, largest to largest. So the smallest here is 5. The smallest here is 1.5. So 5 to 1.5 has to equal middle, which is 11, to middle, which is 3.3, 11 over 3.3. And then largest to largest, 15 to 4.5. Now we want to get rid of those decimals. I'm going to move it once in the bottom, which means I move it once in the top. I get 50 to 15. Move it once in the bottom, which means I move it once in the top, 110 to 33. Once in the bottom, which means I move it once on top, 150 to 45. With me so far? Yeah? Now I got to see if they reduce to the same thing. So what goes into both 50 and 15? 5. This could be 10 to 3. What goes into both 1, 10, and 33? 11. That's 10 and 3. What goes into both 150 and 45? Start with the easy one. What's the easy thing that goes in there? 5. So this would be 30 to 9. Can I divide that again? 3, right? 10 to 3. So are all those equal? Yes. So these are similar because of side-side similarity. But the similarity statement is what triangle is similar to what triangle. So we have to pick the order of the letters. The first time, let's say D, E, F. That could be in any order. But then DE is the middle length side. EF is the longest side. I have to follow the pattern on the other one. The middle length side to the largest. So middle to largest would be W, Y, X. God bless you. So it has two parts. Are they similar? The answer is yes. Side, side, side similarity. If so, write the similarity statement, which is triangle DEF is similar to WXY. No, WYX, sorry. Here we go. You actually, this time, according to the directions, would have just written yes and then that. If it said, are they, Y, similarity statement, then you need all three parts. But this didn't say Y. Questions? Okay, so your test will be 7-1 to 7-4, okay? 7-4 is using similar right triangles. So now everything we talk about is going to be only to right triangles. Everything in this section applies only to right triangles. The first theorem says if the altitude is drawn to the hypotenuse of a right triangle, then the two triangles formed are similar to the original triangle and to each other. So what just happened is we took a big triangle, which has to be a right triangle. Notice that A, it's not very straight, but it is marked as a right angle. That means the big triangle is a right triangle. Then we drew the altitude. So if you remember, the altitude is the segment that goes from the vertex to the opposite side at a right angle. So you should see two right angles in these triangles, okay? One on the big one and one on the little ones. What this theorem says is if that's true, then triangle ABC, which is the big triangle, is similar to both of the smaller ones. The order of the letters is important here again. So if I were to look at the big triangle, where's the smallest side? In the big triangle, what's the shortest side? Looks like AC, right? So I'm going to put an S for shortest. What's the largest side? CB, right? Always opposite the right angle. This is the largest side. And then AB would be the middle, right? So when I name it, if I say ABC, then I went middle length side to the longest side, right? We went middle into the longest. So when I name the other two, I have to follow the same pattern. Let's say I want to name this triangle here on the left, okay? If I start with the middle of that triangle, which one looks like the middle side of that triangle? AD. Yep, that looks like it's the middle, right? What's the longest? AC, right? So this is going to be called DAC, middle side to longest side. Then the last triangle is the one on the right. I want to go in the same order. So what's the middle length side of the triangle on the right? DB, this one, right? What's the longest side on the one on the right? AB. So when I name that one, I have to say DBA. You can rearrange the letters in the first one and then rearrange the ones that follow. It doesn't mean it has to go in that order. But typically, like if you're looking at answers in your book's going to give it to you in alphabetical order the first time and then follow that pattern. So just be careful and make sure you're following that pattern. All three of them are similar. All right, now we're going to learn two proportions that apply to these kinds of triangles. All right, so try the similarity statement. So the first one's already given for you, right? That's the big triangle, QRP. So if I look at the big triangle, and I'm talking short, longest, middle length, QR is which of those three? Of the big triangle. It's the longest one, right? Because it's opposite the right angle. So we went longest. Then RP, right? QR to RP. RP is which length in the big one? QR is the biggest length in the big triangle, right? What's RP? The middle. So I have to go the same order on the other two triangles, right? So if I look at this triangle first, the one on the right, what's the longest side in that triangle? And the right triangle? Nope. RP. How did you know that? Because these kind of look close. How would I know it's the longest? It's always opposite the right angle. That's always going to be the longest, okay? So I know that that comes first, PR. Then the middle length of this same triangle would be what? What's longer, RS or SP? RS is longer. So I go P, then R, then S. Now I want to look at the triangle on the left. I want to go same order, longest to middle. What's the longest side on that? QP. What's the middle length side? Good. So I got to go Q to P to S. Questions? Okay, so that's one of the three things you're going to learn in this section is to set up those side lengths, okay? Again, the order is important. Now we go into two theorems. Well, sorry, this and then two theorems. This is called geometric mean. So the geometric mean of two numbers, is the square root of their product. What's product mean? Multiply. So I'm going to take the two numbers. If I cross multiply this, I get x squared equals a times b. And then I'd have to square root, and the square root of x equals a times b. So whatever two numbers you get, you're going to square root their product. So this is what they'll look like. Find the geometric mean of the given numbers. Let's look at A first. So the square root of the product would look like the square root of 4 times 20. Now I can multiply that out and I get square root 80, but then I have to break it down again anyways because I'm going to leave these as simplified square roots. So instead of doing that, I'm going to leave it like it is and break it down from there. So 4 can be broken down into what? 2 and 2. How about 20? 5. Well, you could do either one, right? 5 and 4, 2 and 10. But either way, you're going to continue to break it down, and you get 2 and 2. You with me so far? So this product, this is called a product of primes. It would be 2 times 2 times 5 times 2 times 2. All of those numbers together would give you 80. The way we simplify a square root is for each pair of numbers underneath the root, one of that number goes to the outside. So there is 2 2's, which means the 2 is going to go to the outside. The 5 does not have a match, so it's going to stay underneath. And the 2 2's, again, bring 1 2 to the outside. 5 stays underneath. So if it has a pair, it goes outside, just one of them. If it doesn't have a pair, it stays underneath. And then if there's more than one number on the outside, we're going to multiply it. If there's more than one number on the inside, we would multiply it. These are going to be left that way. Because think about it, like if I kept going with that, it'd be square root 4, right? And the square root of 4 is 2. So if you have a duplicate number underneath, like 2 of the same numbers underneath the square root, it simplifies by coming out of the square root as a single number.
So what if there's 2 5?
So let's say that there, let me think of 5. So let's say that said 400. All right, so let's break this number down, right? That's a big number. What 2 numbers multiply together to give you 400? And there's lots of different ones you can give me. Huh? 20 and 20. Okay? Right there, you could actually say there's 2 of those numbers, cross it through, put it to the outside. I could do it that way. But you could also take 400, and what other 2 numbers give you 400? How many times does 2 go into it? 2 and 200, right? How many times does 2 go into 200? Because we're going to break this down. 2 and 100, and then 2 and 50, or 10 and 10. 5 and 10, 2 and 5, right? All those numbers come from 400. So I look at only the numbers that are at the end, not the ones that we then divided by. For every pair, one of those numbers goes to the outside. So here I've got 2 2's, one of those is going to the outside. Another 2 2's, another 2 goes to the outside. 2 5's, and a 5 also goes to the outside. This time there's nothing left underneath. There's nothing here, which means I just do 2 times 2, which is 4, times 5, which is 20. So these answers you will not use a calculator for. You will give them to me as exact square roots, which is something like 4 root 5. You don't want to use a square root that's rounded. I'll do the next one with you too, okay? So geometric mean for 9 and 25 would be the square root of 9 times 25. I don't want to multiply that out if I just have to break it down again, right? So what does 9 break down into? 3 and 3. How about 25? 5 and 5. So do I have a pair of 3's? Yep. One's going to go to the outside of the square root. Do I have a pair of 5's? Yep. One's going to go to the outside of the square root. And this is 15. So if it doesn't have a pair, it stays. It doesn't have a match, it stays underneath. If it does have a match, it goes to the outside. The answer is just 15 there. Yeah. If you multiplied that out, you actually get 225, and the square root of 225 is 15. All right. So here's one of two. Here's one of two. All right. This is This is a corollary. Again, like the number doesn't matter. The theorem statement, all that matters is this thing right here. Okay, which yours does not say because I want you to write it in. If you have an altitude drawn in a right triangle, so these are right triangles that have two right angles. One on the big triangle and one on the small one. Then segment 1, which is one part of the hypotenuse of the big triangle, over the altitude, which is the line that runs inside of the triangle, equals the altitude again. So these numbers are going to be the same over the other segment, which we're going to call segment 2. So this is a little proportion you have to memorize. Segment 1 over altitude equals altitude over segment 2. In this kind of a question, you're going to be given 2 of those 3. You're going to fill in your proportion. You're going to cross multiply and divide. All right, last one, and then we're going to use it. This is involving the hypotenuse and the leg of the triangle. So this, first of all, this needs to be a right angle at the top. Please make yours a right angle at the top because you need 2 right angles in these triangles. One on the big one and one on the line that's drawn inside. So this says, again, all those words, but it means this. The hypotenuse of the big triangle over the leg equals the leg over the segment of the hypotenuse adjacent to the leg. And again, these are going to be the same. So I'll even abbreviate it, like when we write it out, it will be hypotenuse over leg equals leg over, and I do the acronym, segment of hypotenuse adjacent to the leg. You don't need to write that whole thing out every time. You just need to know what it means, okay? So now we have 2 of these. Segment 1 over altitude equals altitude over segment 2, and hypotenuse over leg equals leg over segment of the hypotenuse adjacent to the leg. What's the word adjacent mean? Next to. So if I'm going to set up these, okay, where this comes from, the hypotenuse of the big triangle, which is C, over a leg, and you pick one leg. So we're going to do X first. Equals the leg, it repeats, over the segment of the hypotenuse adjacent to the leg. So look at this hypotenuse. Shh, guys. Shh. All right. It's different. I didn't say is it on your person. Actually, it's not on your person. All right. Anyways, this is hypotenuse, which is C, over the leg, and we picked this leg, would equal that leg again, so it repeats again, over the segment of the hypotenuse adjacent to the leg. So the hypotenuse, which is this, right? C is my hypotenuse, is divided into 2 parts, A and B. So when you're setting this up, if I use X, I need the segment that's next to X, which is A. When I go to set it up for Y, because that's the other leg, I still use the hypotenuse, which is C, over the leg, now we're going to pick Y, equals Y, that should repeat, over the segment of the hypotenuse adjacent to that leg, which is now B. So you can set this up 2 different ways. The segment 1 over altitude is only once. But the leg, because there's 2 legs of a triangle, of a right triangle, you can set this up 2 different ways. Okay, we're going to get in an example. This says find the values of X and Y. So if X is here, what part of that triangle is that? Is it the hypotenuse, is it a leg, or is it an altitude of the big triangle? It's a leg, right? So I'm going to use hypotenuse over leg equals leg over segment of hypotenuse adjacent to the leg. So what's the hypotenuse of the big triangle? What's the hypotenuse of the big triangle? 9. How do I know that?
I just added 4.
There you go. You got to add this side opposite the right angle, right? So this is my hypotenuse. I gave it to you in parts, but the whole hypotenuse will be 9. So 9 over the leg, which is x, equals the leg, which is x. Now, what's the segment of this hypotenuse that's next to the x? Yep. Cross multiply x times x equals 9 times 4. What's x times x? X squared, right? Equals, now I can multiply this out. I get 36. Then I got to square root it. What's the square root of 36? 6. So that's for the leg. That's for this. Yep. Now you want the altitude, right? Y is the altitude. So this would be segment 1 over the altitude equals the altitude over segment 2. 1 and 2 don't matter, but what would be one of the segments? What's one of the segments of the hypotenuse? Give me one of the segments of the hypotenuse. We're not leaving till I finish this. 4 is one of the segments of the hypotenuse. What's the altitude? Y. The altitude repeats. What's the other segment? 5. Cross multiply. I get y squared equals 20, and now I want to square root it. Is 20 a perfect square? Nope. 2 and 10, 2 and 5, 2 root 5.